Welcome back to Exposure Stories. Amid the harsh deserts of the Middle East, where nothing exists but rocks, wind, and scorching sun, the people of Israel accomplished something that astonished the world. They carved more than 12,000 kilometers of canals across unforgiving terrain, creating a massive artificial river system that channels billions of liters of Mediterranean seawater deep into an arid nation. But Israel didn't stop there. They took that seawater and transformed it into fresh, drinkable water through cutting-edge technology housed inside enormous desalination plants. This nearly unbelievable engineering achievement raises a question: how does such a system actually work? Join Mandarin Tech as we dive into the story behind one of the most extraordinary engineering feats of our era. For decades, the Negev desert in southern Israel was considered lifeless, dry, cracked, and nearly impossible to cultivate. Summer temperatures soared above 110 degrees F, rain was scarce, and underground aquifers shrank with every passing year. Agriculture, the lifeline of the young nation, teetered on the edge of collapse. Some families survived only on water trucked in from distant regions. Yet just miles away, the vast Mediterranean Sea stretched endlessly, filled with salt water that could not be consumed but existed in nearly infinite supply. This stark contrast inspired Israel's boldest gamble, pulling the sea inland deep into the desert's heart. The Desert Water Project, officially approved in 2000 with funding of nearly $3 billion, represented both ambition and necessity. Israel wasn't just turning seawater into life, it was challenging the desert itself, forcing rivers to flow where nature had never intended. Before any water could be brought inland, engineers needed to transform the Negev's hard, barren terrain into a workable construction zone. They began with satellite imagery, ground-penetrating radar, and thousands of wind measurements to map shifting dunes and identify stable areas. Survey teams lived in the desert for months, drilling hundreds of boreholes, some over 100 feet deep, to study the geology hidden beneath the sand. Every route marker had to be placed by hand with centimeter-level precision. The planned canal alignment avoided wind corridors, areas where a single sandstorm could bury the entire project overnight. Once mapping was complete, hundreds of bulldozers moved into flattened dunes, cut down tall ridges, and redistribute sand to create a smooth, balanced surface strong enough to support cranes and heavy machinery. Conveyor systems pushed excess sand away while compactors pressed the top layer until it became firm enough to function as a stable foundation. To further solidify the surface, engineers discovered that injecting small amounts of water would bind loose grains, creating a denser layer. Giant sprinklers soaked the sand, rollers compacted it repeatedly, and as the desert sun dried the surface, it hardened into a strong, work-ready platform. Only then could one of the largest excavation operations in Israeli history begin. Hundreds of excavators and trucks removed nearly 70,000 tons of sand and soil every day along a 250-mile construction corridor. More than 1,200 engineers and workers labored in shifts under temperatures exceeding 115 degrees F. The canal itself was shaped with a wide U profile, 150 feet at the base and about 23 feet deep, designed to allow water to flow naturally without pumps. Maintaining this gravity-driven flow required a slope so precise that it varied by only 1 inch for every 100 feet. Survey teams checked elevations every 160 feet using laser leveling instruments. Excavated sand was reused to build embankments up to 16 feet high, while weaker soil zones were reinforced with sand piles or cement clay mixtures to prevent sinking. The construction corridor soon filled with concrete batching plants, mechanical workshops, and field engineering camps. Long convoys of trucks and machines moved across the horizon like a mechanical river carving out the path of a real one. Once excavation ended, the next challenge was preventing the desert from swallowing the water. The sand of the Negev is so thirsty it can absorb entire pools of water within hours. To stop seepage, engineers lined more than 220 miles of canal with concrete panels. First, a 2-inch layer of fine sand was spread and leveled. Then 4 5-inch concrete slabs, each 16 feet long and 10 feet wide, were carefully placed with expansion joints filled with hot bitumen sealant. In unstable regions, an extra layer of HDPE geomembrane was added beneath the concrete, anchored with steel pins and protected by a sand cushion. To stabilize the embankments, vetiver grass and desert acacia were planted along the slopes. From the air, the canal looked like a shimmering silver ribbon cutting through endless gold, a concrete artery awaiting its first life-giving water. But a canal is much more than a trench. It requires a vast network of support structures: bridges, drainage culverts, spillways, siphons, and aqueducts. At the system's head, massive steel gates control water intake. Along the route, more than 900 engineering components regulate flow, allow traffic to cross, protect against floods, and ensure natural waterways continue unimpeded. Distribution gates placed every few miles feed secondary canals that deliver water to farms and towns. Any malfunction, a jammed gate, cracked aqueduct, or blockage could deprive entire regions of their only water supply. Every structure had to perform perfectly. After more than 15 years of construction, the project entered the water testing phase. Engineers slowly opened the gates, letting river water flow through the canal in stages, first 500 cusecs, then 2,000, and finally 6,000. Teams inspected the canal at every step, searching for leaks and monitoring pressure and ground movement. When water first rushed through the dry canal bed, entire regions erupted in celebration. Locals called it the day the desert came back to life. Wherever water flowed, cheers followed. It was not simply the movement of water but the movement of hope, something generations had waited to witness. Yet the Mediterranean seawater could not be used directly. Salt in the desert is even more deadly than drought. Before the water could sustain human life, it had to pass through an intelligent desalination chain. Seawater first went through mechanical filtration, sand settling, and oil separation. Then came fine membrane filtration to remove algae, bacteria, and tiny particles. The heart of the transformation took place inside reverse osmosis chambers. Under immense pressure, seawater was forced through semi-permeable membranes so fine that only H2O molecules could pass. Salts, heavy metals, and contaminants were left behind. The resulting water was extremely pure, so pure in fact that essential minerals had to be added back. Calcium and magnesium were carefully dosed to rebalance pH and restore natural taste. Ultraviolet light or ozone disinfected the water, and a trace of chlorine ensured long-term safety in the distribution network. Every stage was monitored by sensors and tested in laboratories. Only when purity standards were met did the water enter underground pipelines and begin its hundreds-mile journey across the desert, not seawater anymore but a true lifeline. When the first freshwater streams reached the Negev, everything began to change. Land that had once cracked beneath the sun turned green. Farmers returned, planting orchards, vineyards, wheat, vegetables, and date palms. With the help of Israel's pioneering drip irrigation technology, every drop of water was used with maximum efficiency. The national water carrier, constructed earlier in the 1950s and capable of transporting 72,000 cubic meters per hour, became the backbone of this renewal, connecting north and south in a green ribbon visible from satellites. Villages were rebuilt, schools reopened, and modern high-tech agriculture rose where only sand had existed. The desert did not merely bloom, it transformed. This is the story of how Israel moved billions of tons of sand to create one of the longest artificial rivers on Earth, and how technology turned seawater into drinkable life. If this achievement amazes you, let me know. Thank you for joining me and stay tuned for the next video.